Hi, good morning. So today I would like to talk about something that you probably shouldn't care about. I heard this last year at KubeCon. Developers don't care about RPC technologies. Well, and you as a developer, you probably shouldn't have to care about what RPC technology you use, or in a perfect world, right? But where we are in an imperfect world, plumbing in our infrastructure tends to bleed into our work, into your work. And let's not forget, the plumbing, the infrastructure is actually exciting by its own. And I assume that's also the reason why you're here, listening to me talk about plumbing early morning. So my name is Mattias. I work at Spotify as an engineering manager in core infrastructure group. And at Spotify, we've made the decision to move away from our own proprietary protocol for service communication to adopting gRPC. As a manager by trade and an engineer by heart, I love the intersection between leadership and technology. So we will talk about both today. We'll talk about why we choose gRPC, about the technical aspects of gRPC, why we are excited about it, and we'll also talk a bit about how we move over to gRPC, because that's a pretty big task to move everything from one protocol to another one. So let's start with the why. It's really two parts. Why do we need to change from what we have today, and why do we choose gRPC as an alternative? A little bit of background. Spotify's backend is built to handle serve approximately 200 million active users, monthly users. We tend to see roughly 8 to 10 million requests per second towards the backend from the clients, so the mobile clients or your connected speaker. Roughly, we're a little bit over 1,000 developers at Spotify worldwide. Together we build, design, and maintain 2,500 services, or microservices, if you will, in the backend. Those services are mainly written in Java, some of them in Python, and a few other ones. But the main language here is Java. And those services most of them communicate synchronously with each other with something, a proprietary protocol that we built at Spotify called Hermes. Hermes is named after the Greek god Hermes. It's the messenger for the emissary and messenger of the gods, so it's kind of pretentious, yes. But we tend to name everything after Greek gods at Spotify that we build ourselves, especially historically. Hermes was built 2012, 7 years ago. Was built because there were limits that we were reaching with HTTP back then. So it was built on top of 0MQ. It's not really a full-fledged RPC framework, as gRPC is, but it defines on how we do messaging and how we do serialization marshalling. Service authors choose if they want to use JSON for serialization on payloads or binary protobuf marshalling. So that's when we started using Hermes. And the thing with Hermes is it works, right? I mean, we have been around for some time. We have grown quite a bit over the last few years. Some of you might use Spotify, and I hope you don't experience a lot of outages. And that's also thanks to Hermes. Hermes works, and it's solid, and it's performant. We have been able to scale to quite large numbers with it. So why do we want to change? It's really not about Hermes, the technology behind Hermes, or bugs or anything. It's more about speed and time to market. When writing Hermes servers and clients, we need to write a lot of handwritten boilerplate code, right? Every integration between services usually creates quite a lot of handwritten code. And it's also often a kind of a blocker to adopt different technologies. The biggest problem with Hermes is really its ecosystem, because there isn't any. Hermes is internal only, it's not open source, So we depend on ourselves for everything, which is a problem. Because let's say you want to use a load balancer, like Nginx, or Amazon's Elastic Load Balancers, or Envoy. Well, that's not going to support Hermes. Or you want to use some fancy new caching library. Nope, doesn't exist, you have to write it yourself. Maybe you want to use a shiny new service mesh. Out of luck, you can't use Hermes with a service mesh. Or maybe you have some tooling that you need to debug your services. Maybe you want to use Postman or something else, something built in your IDE. That's not going to exist either for Hermes. So everything has to be built in-house. And that's the problem. If we zoom out, this is really our journey away from our own kind of built solutions towards a future where we adopt open source and best practices and kind of across the industry. Because we realized that we shouldn't be in the business of building protocols. The same as we also realized a few years ago, so we don't want to build and maintain data centers. That's why we moved everything to the cloud. So all the backend is in Google Cloud nowadays. Same goes for protocols. Same also goes for container orchestration, for instance. We have our own tool, and we migrated everything to Kubernetes, and we're still doing it. So that's one of those journeys. So now we know why we want to move away from Hermes. Why do we want to adopt gRPC? Well, there's a lot of different factors that pull us towards gRPC. gRPC is open source. It's open. It's adopted by many companies. It's backed up and sponsored by the Cloud Native Compute Foundation. That's the same foundation. That's a daughter it's a subsidiary for the Linux Foundation, and it's also a foundation that hosts Kubernetes, Prometheus, and other big open source projects. So it gives us kind of confidence that this thing is going to stay around. gRPC was initially written by Google to replace their own in-house protocol called Stubby. And when it was open sourced, it was quite quickly adopted by big companies in the industry. It's built on top of HTTP2, so open standards. It comes built in with encryption, and it's easy to add authentication. It supports request response patterns and streaming, unidirectional, bidirectional. There's a lot of features in gRPC that are very appealing. And it's kind of an opinionated framework, so you get a lot of things with it. I would like to talk about 3 things that we felt really were big benefits to us. And we're going to start with the Proto file. So in gRPC, the payloads are protobuf binary blobs, but also the interface is defined in a protobuf definition file. And that file really it's one file, it's human readable, and where you define your API, so to say, for gRPC. And that's the power with that, it's strongly typed, so you can, from the proto file, you can generate code. You can generate both server code and client code in many languages. So we don't need to write that much boilerplate anymore. And we know the code is generated by a bigger project that follows best practices. We get a whole bunch with that, many features with that. We don't need to do any custom serialization to JSON and back. We don't need to handle checks and dependencies anymore, or we don't need to do any JSON magic. We can just use generate code, and you get in your language, in your platform, you get native classes in Java or modules in another language that you can interact with. So this is a huge win for us. So some of the services in our backend that are highly used, they have dozens and multiple dozens in client implementations. All of them are a little bit different. All of them have their own bugs. And this is a big problem, and it's a big source of bugs for us and issues. Okay. Once you realize that Proto is it's a pretty cool thing, you want to be able to manage those schemas. So the Proto file really is your source of truth, and it took us a while to understand what that meant. It's not just an internal implementation detail, but it's the Proto file itself that you want to make a first-class citizen when you share your API and document it. This is your main documentation of your API, and from that you can generate everything. Documentation, client code, server code, and tooling on top of that. We started out with saying, okay, we have a Proto file, and we generate jar files from that, and then those we distribute. We abandoned that approach because nobody else is doing that, and we didn't want to build ourselves into a Spotify-specific corner again. So the Proto file is really what you want to have as your single kind of main artifact. Once you have that, you want to share them, right? You want to share them between teams. At Google, when they create gRPC, that's quite easy for them because everything is a monorepo. For us, that's not as easy. We don't use monorepos. So our approach was something in between. We do a shared repo approach where we encourage teams to upload the Proto Files to a shared repository in Git. And in that central place, we can lint Proto Files, we can check them, we can test them, and we can also kind of do some compatibility checks, so we can be sure that things are always backwards compatible. And the third thing we learned is around versioning. So we were used to version libraries and SDKs and jar files according to semantic versioning, but instead with Proto Files you don't want to do that. Only thing you want to version is major versions, breaking changes, and basically a breaking change means you create a new gRPC endpoint. And that in gRPC speak, that would be a new package in gRPC. Everything else you can depend on that things are backwards compatible. And so a client that uses V1 of your service, you might want to add features to V1 without breaking anything. And that client, as long as they don't need those features, don't need to upgrade their client. They just keep on using it and it keeps on working. Once you start removing things from your endpoint or renaming and reordering things in your Proto File, that's a breaking change. That's when you have to introduce something new. So a common pattern is you have V1, you want to do V2. It's not quite settled yet, so you call it V2 beta 1. This approach is also what's used if you use Kubernetes. That's how Kubernetes exposes its APIs and versions them. There is a bit of tooling around Proto Files, but it's not quite there yet. So there is tools like Prototool by Uber that helps you manage protobuf files. There's a tool called Buff that we recently discovered that gives you a repository and helps you manage and resolve dependencies. I think it's good to watch that space because there's going to be a lot of tooling being created in the near future, we're sure. Another big area I would like to cover is resiliency. Because gRPC comes with a lot of tools and features that help you implement resiliency patterns that we didn't have really in Hermes. First off, retries. So with the help of gRPC, you can easily and transparently handle retries. So the client calls a service, the call fails, your application code doesn't need to know that the gRPC client just retries automatically for you. And that's configurable. If you don't like that, you turn it off. But it's very easy to start using it. Today, those retries are solved with what's called interceptors in gRPC. Think of them as middleware in gRPC's land. But there's a proposal ongoing to move that into the core libraries. And with that proposal, there's also new additions, things like retry hedging, which we think will help us a lot. If you use Cassandra, that's called backup requests there, or it might be referred to as speculative retries. So the idea is that you send the first request to the server, that times out or fails, and after a certain time span, the client will fan out and send multiple requests to other backends for you and waits for the first reply. So the fastest reply comes back and is sent to your application code, and all the outstanding requests that we're still waiting for are cancelled. So we basically first do a serial request, and if that fails or takes too long, we parallelize. That helps you to dramatically cut your tail latency in big call graphs. There is a problem with that, of course. It's because you're gonna spend quite a bit of more resources on RPC, right? Because every client might talk to 10 different backends, and that's particularly a problem if you have problems in the backend, right? It's really a good way to start cascading failures. And the sounding herd problem. You might have a service that's kind of feeling bad, unhealthy, is down, and clients keep on hammering it with requests. It's going to make it really hard for that service to come back up. So gRPC also, in that same proposal, has solutions around that. They're nothing novel, but the nice thing with the gRPC, they come built in. One of them is retry throttling on the client side, and then you have pushbacks on the server side. The throttling is basically, think of it as a request quota. You have a bucket of requests that you can send from the client, or retries, not retries. And once they're used up in a certain time frame, the client will stop and back off. So that will help you a bit. And then on the server side, the server can, through metadata in the request path, can signal that to the clients, please hold off for a certain amount of time. We need to figure out something here. So it's basically a way to push back and to create back pressure into the call chain. And that's, with that work ongoing, that will be all built in gRPC, which is a big win, because where we are today with Hermes, but also with HTTP, those things you usually have to build ourselves, or you have to use some third-party library to integrate that. Another feature that helps you is called deadlines. It's similar to timeouts you might be aware of, but in gRPC, a deadline is really a way for the client to signal how long it's willing to wait for a request to be responded to. And it's usually a deadline is defined as a fixed point in time, so let's say 4 o'clock on Friday afternoon, instead of a relative time like a timeout. Deadlines are really useful compared to timeouts when you have long call graphs, and when it gets hard to kind of align all the timeouts. With deadlines, everything is a fixed time, so if you have a call that goes through several services down and you reach a deadline, everything can be canceled at once, and there's no and resources can be freed in a controlled way. So that's also quite exciting. Our tip, and what we have understood with talking to others and experienced ourselves, is to always set a deadline. There's an interceptor, for instance, in Java that you can set that will not accept any requests that don't have a deadline defined. That we believe is a good practice, and we actually enforce that for everything now that builds gRPC services Spotify. Because if you don't set a deadline, you automatically use the maximum timeout, and during that timeout, you use resources, memory. And if you have a large scale, that's a big problem. So deadlines are good, make use of them. And also makes it explicit of what you expect. How long does it make sense for you to wait as a client? And if you don't get a response in that time, you can handle that explicitly. The third thing I want to talk about is load balancing and routing, which I think is really exciting. So load balancing, most of you might be using server-side load balancing. You have a proxy, like Nginx or Envoy or some managed solution in front of your services, and the client talks to the proxy, and the proxy then load balances across your backends. The good advantage with that is the client doesn't need to know anything about load balancing. It just talks to the load balancer, and the load balancer has all the logic about how to balance traffic. The downside can be that you have an extra hop, right? Every request jumps through a load balancer, so you get a little bit lower latency. If that might be a problem for you, it might be not. Another approach is client-side load balancing. That's also nothing new. You don't have any proxy. Clients talk directly to servers, backends, and the client themselves load balance and have all the logic built in. So the clients will health check the backends to realize figure out who they talk to. They will discover all the backends, and then they will have some kind of logic to load balance between them. It might be as easy as round robin, it might be a random selector, or it might be something more advanced where it tries to determine expected latencies. At Spotify, since there is no proxies for Hermes, everything is client-side load balanced. A big win with client-side load balancing is that it has low latency. You don't have any extra hop. The big problem with it is it's very complex clients, and that's the source of bugs and problems. And also, if you have a very large deployment, every client is basically health checking every backend. That can be in itself a problem, where health checking traffic becomes almost bigger than actual data traffic. In gRPC, they support both of those. Because it's HTTP2, you can really do both. And then there's a third solution, which is called a look-aside load balancer or external load balancer. The idea here is that we combine the advantages of the client-side load balancing, where we don't have any proxy. Clients talk directly to the service. But the clients don't need to know everything about how to do load balance. There's an external piece of load balancing software that tells them how to do that. So that's a diagram from the gRPC project. The light blue boxes are the service. You have the green box is your client. The client will receive a list of endpoints from the dark blue box to the right. That's the external load balancer. The external load balancer will continually check the health of the backend update that list, and send it to the clients. And then the clients will, depending on what policies they use, choose one of the backends. And that can also be controlled centrally. And the cool thing is this already works with gRPC. What the gRPC upstream project is doing right now is actually evolving that into something more generic. Because if you look at that diagram and kind of tilt your head, it starts to look that load balancer on the side. If you flip it to the top and you call it control plane, it looks awfully close to a service mesh. And that's exactly what the gRPC is doing right now. What they're doing is they're implementing the XDS data plane control interface that Envoy introduced and that is used by other proxies nowadays. They expose that implement that in the gRPC client so that control planes like Istio or other Linkerd, for instance, can control gRPC clients without the need for any proxies. So you end up with a service mesh where you don't need to deploy Envoy proxies, sidecar proxies. And this is a huge win. I mean, it's not going to replace the traditional service mesh because gRPC is never going to implement all the features that a real proxy has, but some of the use cases that you might be using it for will be supported. The advantage with this is two. Well, first is lower latency. You don't have any proxy on the critical path, on the data plane. And the second one is it's much easier to deploy, right? You don't need to handle sidecars anymore. The only thing you need is a gRPC client in your application that has a certain version, and then it can be controlled externally. So this is currently work in progress. If you go to the gRPC Java, it's built first in gRPC Java. If you go into the project on GitHub, you will see a branch that's called XDS. I don't know what the timeline is, but this is something that we are looking forward to, and we try to get involved in. Okay, so those are three reasons of why we think gRPC is great. There's many others. So Proto Files are really powerful. That is the kind of the strict typing, code generation, resiliency patterns built in, and then routing and load balancing, which are really exciting. There's there's another reason why I think gRPC is a good choice, and that's their mascot. So gRPC has that dog as a mascot. The name of the dog is Pancakes. If you wonder why it's called Pancakes, well, in the community of gRPC, there was this discussion what gRPC stands for. Does it mean Google RPC or general RPC? And then the project said, or somebody said, no, it's not anything of that. It means Golden Retriever Pancakes, gRPC. So that's the Golden Retriever Pancakes. That's a mascot for the project. And I mean, that's a good reason to use gRPC. There's different versions of that most mascot. The protoc and serve. Protoc, that's the compiler that compiles your Proto Files into code. I love that one. There's different variations of the same. And I'm really happy that we have even our own. A colleague of mine, together with people at Google, built our own mascot for Spotify's Pancakes. If you're interested and like that image, I have stickers with me. And come see me after the talk. Okay, so how do we move to gRPC? How do we do this? I mean, it's quite big or a lot of work to change something as fundamental as an RPC framework in an existing backend as big as ours. In any backend, really. How do we convince our engineers that this is something we need to do? Because engineers and developers at Spotify, they tend to build features that hopefully you, our customers, can make use of. They're not interested in migrating yet another thing. Because we already tell them to migrate to Kubernetes and other things, now we come and say, look, now we also have them with gRPC. They get tired of that, right? So instead of forcing them to migrate, we need to find a good reason for them to migrate. And the first thing to understand is that this is a long journey. Right? It's not going to be something that we do in a week or a few months or even a year. It's not something that we do centrally. It's not that my team can do that for everybody else, because it needs to build an API, needs kind of domain knowledge, and the service teams, of course, has to be involved in that, or actually drive it. How far have we come so far? by now. So we're around 40% of our services that expose Hermes endpoints also, or now expose gRPC endpoints. That there are services that are still transitioning that kind of expose both Hermes and gRPC, and maybe also HTTP, and services that have already migrated. It's the biggest challenge is, of course, the services that have a lot of dependencies, that a lot of clients. We can't just force everyone at once to switch. So they usually are in a transitioning period where they support both for a long time, where the gRPC is just added as yet another API, and then once clients are migrated, the old Hermes endpoint can be closed down. Other ways that they do it is, for instance, they break out Hermes into a sidecar which just does Hermes stuff, and then the service itself can be a gRPC pure service. Those are different tactics that people start to adopt. The journey really is a little bit more nuanced because we really want to get people off of Hermes, right? So the end goal is to not use Hermes anymore. So if people instead choose HTTP or REST or event-driven architectures, that's also fine. I mean, we really would like to encourage them to use gRPC because I think there's a lot of benefits, but in the end of the day, we want to get rid of Hermes. So we count on teams that own services to do that migration, and in order for them to do that, we need to give them a good reason to kind of drive and manage that change. And the thing is, change is hard, right? Because change really threatens what we find familiar. And familiarity is usually something that feels nice and comfortable, something that we know, something that gives us a sense of security. It's not always a good thing, but it's something good to fall back on. So we're not going to get anywhere by just forcing people to migrate, and we're not Jedi either. We can't play any mind tricks. So we really have to get people and teams to want to migrate on their own. Let me talk a bit about autonomous teams, because at Spotify we pride ourselves, our organizations, working with autonomous teams where we have little top-down management and teams get to decide how they work and how they solve problems autonomously. In order to be able to have an autonomous organization, you need a lot of trust in the organization, right? Leadership needs to trust engineers that they make the right decision. Every engineer at Spotify has access to production. At the same time, engineers also need to be able to trust leadership that if they do something that might end up in a problem or an incident, that there's not going to be any repercussions, that there's not going to be a blame culture. So this mutual trust needs to be in place. And also, one thing that a lot of companies struggle with, and including us, is it's easy to confuse autonomy with freedom. That's not the same thing. It's really, usually freedom is a sign of lack of accountability, whereas alignment really needs accountability to be in place. So you achieve, autonomy needs accountability in place, so you achieve alignment. I think that drawing from Henrik Nyberg shows that pretty nicely. You have, on the vertical, you have alignment. On the horizontal, you have autonomy, where we want to end up in the top right corner, where we are highly aligned and we have autonomy. Those people feel empowered and they feel passionate about what they're doing, and we run in the kind of channel the same direction. We want to avoid being highly aligned without autonomy. That's the top left. That would be top-down management. Everybody's kind of dismotivated. People just do what they're told, but that doesn't scale, and it's not really a fun place to work at. We also don't want to have high autonomy and low alignment on the lower right, because then we are in the place where everybody feels like I'm free, I can do whatever I want, but we don't actually make any forward progress. So we want to be on the top right. Low alignment and low autonomy, I don't really know what that looks like, but that's probably not a nice place to be in. So aligned autonomy is what we're looking for. What we really want to get to is how do we get alignment on this common goal of replacing Hermes with gRPC. We have 3 different strategies. The first one is what we call the golden path. At Spotify, this concept of golden path is you see, this is now a picture of our development internal portal, where people have access to what we call the golden path in different domains. The backend golden path is the one that's relevant here. It's a document and kind of a tutorial for new joiners to learn about how we build stuff at Spotify, but it's also a way for us to signal an opinionated approach to building backends and services at Spotify. So think of the golden path as kind of the paved road. If you follow and walk that path, you will get things for free, and you get integrations working without you having to do much. The tooling that we build in infrastructure is built around the assumption that people use the golden path. You don't have to walk the golden path. You can walk stray off the path, but then you're a little bit more on your own. You can't account on support from the support infrastructure and support structures. So it's a way to not force people, but still get alignment. It's really a way to make the right choice, to be the easy choice. And that's accountability comes in when people stray too far away from the golden path, that maybe somebody will tell them, well, why do you do that? Why is it worth? Why do you want to set up your checking machines through 2 months if you just get it for free if you do what is described in the path? That's what we mean with accountability, where we keep each other accountable. It's not just manager to engineer, but it's also engineers between each other. A second thing we need to create is carrots, or we're kind of dangling it from the teams, right? They want to migrate to gRPC because there is a lot of incentives to move. It's really an exercise in gamification. There might be the code generation thing might be a good carrot for some teams, or resiliency patterns that we talked about, load balancing, but really also any tool that's out there is really a carrot because none of them can be used with Hermes. And the third option really comes into play when we need to kind of accelerate migration. We are not there. We don't know if we get there, but in case the migration takes way too long, and they feel like, okay, now we have this never-ending migration, we just add yet another protocol, and everybody suffers from that. We want to get out of this as quickly as possible. That's when we kind of force the migration. And which really, if you think of it as kind of the stick to the carrot before, that could look like where we say, so the team I work with, we own and maintain Hermes, the protocol and the implementations. The team could say, well, by the end of the year, Hermes will be no longer maintained. So security fixes will not be done on Hermes, or no new features, no support. That will be a really big reason for people to move away from Hermes. We try to not use that option yet, or not at all if possible, but that's always kind of the break the glass kind of way to force the migration. So our journey is long. We spent last year and the beginning of this year a lot of work, pre-work to kind of get off the ground. Now we hope that the journey is kind of smooth sailing. Half a year ago we were at 10%, now we're at 40%, so we're happy with the progress so far. We hope once we land in where we want to be, looking back it won't look like that. We hope that people looking back at the migration once it's done will have looked like a well-managed and meaningful migration. So to round this off, I would like to change this, developers don't care about new RPC technologies, to developers don't have to care about new RPC technologies. Thank you. I have time for questions, or you can also feel free to come up afterwards and ask me questions. I'll stick around. I see a question over there. Do we have a mic? No? Do you want to come up?
Regarding schema management, some of this, your schema stretches out to all the way to the client and through internal RPC and then to the data lake where things are stored, right? And in some cases, these records are in common or have common properties, but so they are similar but different.
Yes.
Can you comment on if and how you share definitions between these three environments?
So in gRPC, you support importing or depending on different definitions, right? So we have one where we have a common file where we store very common things. We try to not do it too much, but let's say we use it for user data that are common to Mary requests or metadata that we send in. So we have that also in the shared repo, and then the proto definitions can depend on it. And then we have some very light tooling. When you download a proto file, it fetches also dependencies. the Proto Files into your workspace working directory. I have more stickers, wait. Does that answer your question?